Today is April 16 of 2025. I did linear regression and logistic regression. For linear regression, I used this data set, which has 79 explanatory variables. And to predict final price of each home is our thing, what I'm doing. So I I I I use data set which is following, and I loaded data set. So first what I did is plot a histogram and box plot and box plot, and there's two more ways. There were four ways of visualization was possible. There was four ways of visualization is possible. Each of the visualization that there was things that you can check for histogram and box plot and correlation plot and so on. So for box plot, I use distribution, and for histogram, I also see the distribution. So I calculate IQR, which is Q3 minus Q1. And after that, I do the removing outliers, which is outlier is defined by with doubly linked list. Outlier is defined by double linked list, and histogram, box plot, and correlation plot, so on. So there was four visualization tool cases for visualization tool. So I calculate the IDs, and right now I use outliers.index, but you can use outliers.values or so on. And if there's null value, I also print the names, and I made another X1 dataset, which is remove outliers. So I print out all the dataset with X dot shape 0, and shape 1. IQR, and for ways of visualization on to box plot, and correlation plot. Okay, I will keep going. So after that, what I did is making new data set. And I calculate variance inflation factor. This is really important. Variance inflation factor is defined by 1 over 1 minus r squared, which is related with correlation related with r squared, basically related with r squared. So if it is r squared is related close to 1, then it will go to infinity. That's super high. Then which means both of the variable is kind of collinear. So if VIF is high, which means working indicates collinearity. So you should remove it. In this case, or when you remove some variable which is high, but when you remove some variable, other VIP goes super high together. We sometimes call it with names. It's important in econometrics and others. And so based on it, we create new data set after removing certain variables. And we calculated, after that, we calculate Pearson correlation coefficient of explanatory variables in X2. And we also select top 5 explanatory variables. So this is the result. This is the correlation between target variable and each of the variables. And then what we did is, using this, we make linear regression model. When we make linear regression model, we calculate, we can just use it. We calculate y prediction and residuals. Based on residuals, we calculate RSS and so on. And we calculate covariance metrics. And based on that, we can make result of variable coefficient, standard deviation, t-value, and p-value. And after that, what we did is f-test with our result, or we already have it, and we just divide it by each of freedom. ESS is as p minus 1 of the degree of freedom, and RSS as n minus p of degree of freedom. And we can calculate R squared, which 1 minus RSS over PSS, and also we can calculate R squared based on degree of freedom. And based on that, we are doing log transformation. If you do log transformation, this is log graph, so we can diminish the number of the outliers. So after log transformation, it more look like normal distribution with target variable. And after that, we calculate IQR again, and upper bound and lower bound again. And after that, we make new variable. And based on new variable, we are computing again the correlation coefficient and so on. So this is OLS summary after that. And perform f-test again. Yeah, and we're calculating linear regression and make QQ plot. So is it normal distribution related to normal distribution? And after that, we are calculating residual plot. If it is, it has same depth each other, it is good. And we are also did logistic regression, which is magic gamma telescope data set, which has 2 classes, G and H. So I imported and I select 1 variable from 10 variable and train 10 different logistic regression models. Select 1 variable and extract and train 10 different logistics model. If you see accuracy, then each of the variable accuracy is the same. Based on that, we calculate high variable. In this case, it was all same. I'll just choose it. And this is basically the logistic regressions decision boundary, and this is actual class GNH. If you see, we kind of distinguish it well. And we will calculate accuracy. If it is accuracy, this is accuracy graph. Thank you.